Hi, this is the South County Math Tutor here to do a very basic Calculus 1 review worksheet. A note about the problems. I did not come up with all these problems by myself. I just did some basic Google search and compiled some problems for that. Okay, so I'm going to go ahead and get started here. I need to get started. Great. Okay, so let's go ahead and get started. Um, what problem number one? Um, Problem number one. Okay, so really basic. Find the derivative of the given function. So notice this is just a simple derivative rule. There's no chain rule. There's no quotient rule. There's no power rule. Just derivative. Okay, so this is 4 times 2 is 8, x cubed minus 6, and that's it. So f prime of x is 8x cubed minus 6. On the second one, um, x squared plus x over x. Okay, so you look at this, and a lot of you might look at it and just say, okay, we can do a quotient rule, but actually that's harder than I want to make it. So what I want to do is go ahead and simplify this. I noticed that I can factor out an x in the numerator because x squared plus x has x in common. So I can factor that out over x and check out what happens. The x's cancel out and you just have f of x is just x plus 1. Well, the derivative of a variable x is just 1. So f prime of x equals 1. Okay, so if you forget that, you can always do the quotient rule. It's just going to be longer, and it's just going to be longer. Okay, so number 3. Whenever you see a radical, make it a fractional exponent. Okay, so this is the square root of x. The square root of x is saying x to the 1/2. I don't know why I put a parentheses on that. Okay, square root of x is x to the 1/2. So 6x to the 1/2 f of x, because square root, so this is 2, so that's why that's the denominator and the power is 1. Okay, so f prime of x, go ahead and bring this to the front and multiply it. So 6 times 1/2 is 3x minus 2 over 2 minus a form of 1. So this would be 3x to the negative 1/2, which is saying fractional negative exponent just makes something um, changes position. So since it was on the top, that just means this is x to the 1/2. Okay, so if this is a multiple choice test, you will they'll probably turn it back to a radical, and they could actually simplify this even more. So because we usually don't like radicals in the denominator, so you multiply by a form of 1 to get rid of that radical in the denominator. So this equals 3 squared of x over x. Okay, so any of these would work. Just it all depends on the form that they want it, but chances are this final solution, this is probably how you will see it in a multiple choice exam. Okay, this t cubed times t, I'm going to go ahead and change that to a fractional exponent plus t. Okay, you could either distribute and go ahead and do it that way, so that's what I'm going to do. Okay, to me that's easier. So t cubed times t to the 1/2 is cubed is the same thing as saying 6/2. So this would be 6/2 plus 1/2 is 7/2. Okay, and thankfully this is just t to the 4th power, and that's a plus. Okay, so remember, when you multiply something same base, you add the exponent. Okay, so derivative. So this is 7/2t. So this is -1, which is -2/2. So this is 5/2 plus 4t cubed. Okay, I'm doing this really quick because I believe that you, at this level, you should be able to, you should know your rules of derivatives. Okay, so I distributed and I did that. Okay, so you could also use the power rule, of course. The product rule is what I meant by that. Product rule. All right, not example 1. Next question. I guess this is question number 5. Okay, if f of x is x cubed sine x, find f prime of x. All right, so this is product rule. So f prime of x, I like to be consistent, so I always do u prime v plus v prime u. So the rule is u prime v plus v prime u, and usually in textbooks they write it just they flip the order, but I like to use u prime v prime u because I like to be consistent so I don't get confused with my quotient rule. All right, so this is my u, so the derivative of x cubed is 3x squared times v sine of x plus v prime u, the derivative of sine of x is cosine of x positive times x cubed, times x cubed. Okay, so I'm just gonna simplify. So this is just 3x squared sine x plus x cubed cosine x. Okay, that's that. Product rule, same things. So this next problem is going to be interesting. I can already tell. So let's go ahead and get started. Okay, f prime of x. Okay, so the derivative of the first function, sine of x, is cosine of x times v secant x plus the derivative of secant x is secant x tangent x times u, so sine of x. Awesome. All right, so we are going to simplify this lovely mess. We know that secant is 1 over cosine of x. So 1 over cosine times cosine. Check this out. These two cancel out, and you just have 1 as a placeholder. Okay, so let's see what's happening here. We know that secant is 1 over cosine again of x times tangent x times sine x. Fun times. Okay, so on this side, I have sine x over cosine x. If you know your trig identities, sine x over cosine x is the same thing as tangent x. Okay, so this is not so basic problem. This is a not so basic problem because you just have to know your trig identities. Okay, so tangent times tangent is tangent squared. Tangent squared x, and this lovely problem is done, and oh, how exciting. Okay, next problem. So this is problem 6, and let's not call that example 1, let's call that problem 7. Number 7. Great. Okay. Find the first three derivatives of this lovely function. It's not really it's a basic function because it doesn't involve product rule, quotient rule, chain rule. So that's good. So we're just gonna do it. F prime of x, so the first derivative is 4 times 5 is 20x cubed minus 6 times 3 is 18x squared minus 2x plus 1. Okay, second derivative. 20 times 3 is 60x squared minus 36x minus 2. Okay, and f triple prime. So third derivative is 2 times 60 is 120x minus 36. Notice how for each derivative is going down 1 degree. Okay, and that's it. So first derivative, find the derivative of the function. Second derivative, find the derivative of the first derivative. Third derivative, find the derivative of the second derivative. Excellent. Okay, moving on. Limits. Okay, good. Let's do limit problems. Okay, so this would have come before the derivatives, but that's okay. This is just a review. So limit as x approaches -8. First you try to plug it in, but notice if you plug in the -8, it makes the denominator 0. So we need to figure out how we can do this um, to avoid having a 0 denominator because that's mathematically undefined. So I look at this function and I see that I can factor the top. So that's what I'm going to do. This is a basic function, basic factoring problem. You don't really need too many rules to do this. I know that 8 times 5 is 40, negative positive 8, and -5 combined together will give me a positive 3. So those are the two numbers that I want to use. And look, it turns out it works out really well for me because these two cancels out. I can eliminate those two. Now I don't have that negative in the denominator, and I can just plug in -8 to find the limit. So limit as x approaches -8. Well, if I just plug in -8 minus 5, I get that the limit is -13. So if you can do some mathematical kung fu, go ahead and do that. And what I mean by that is try to simplify and cancel out so that you don't have those um, undefined problems. Okay, number 2, limit as x approaches infinity. Okay, it's an infinity problem, and notice how the highest coefficient on the top and the bottom are the same. So when you have those two the same, all you do is you just take the coefficients, 4 over 2. So the limit as x approaches negative infinity is just 2. That's a pretty simple problem, but very exciting. All this. Find the instantaneous rate of change of f of this function at 1. Instantaneous rate of change is also another way of asking for the derivative at this point. Okay, so f prime of x. So you find the derivative. So that's 6x minus 4. And then at x equals 1, so once you find the derivative, you plug in 1 for your derivative, for the x value of your derivative. So 6 times 1 minus 4, which is 6 minus 4, which equals 2. Moving on. Okay, following piecewise function. So f prime of x is equal to just regular derivative. So this is 4x cubed negative plus 2 for x less than negative 5, and it is 3x squared for x greater than or equal to negative 5. Moving on. Okay, please know this notation. Okay, so y prime, first derivative is 5 cosine 6x times 6. So it's kind of is a variation of the chain rule. Okay, so 6 times 5 is 30 cosine 6x. Okay, y double prime. Second derivative is 30 negative, because now we're dealing with cosine, and the derivative of cosine of x is negative sine of x. 6x, and don't forget to multiply it by what's inside. So times 6. So 6 times 30 is negative 180 sine 6x. Okay, so third derivative, y triple prime, is same thing, sine. So derivative of sine is cosine. So this is negative 180 cosine of 6x times 6. Okay, so 6 times 8, 54. Let's do that. 18 times 6, I got it. Okay, 6 times 8 is 48, so it can't be 6 times 1 is 6, 108. 1080 negative cosine 6x. That is my final answer. Take it or leave it. Okay, moving on. An object is moving in time. That's good. I'm glad the object is moving. See what's happening here. There's over time, interval 0, 4. Find the velocity and acceleration as a function of time. Give the appropriate unit of each. Alright, let's go ahead and do that. First things first, velocity is change in distance over time, which is the same thing as first derivative. Okay, so the first derivative of this function is 6t minus 6. Okay, acceleration is the same thing as second derivative. And it says, well, the velocity is just meter per second. Okay, second derivative, so the derivative of the derivative, so this is just 6. And meters per second squared is acceleration. Okay, evaluate S of t, v of t, and a of t at 1 second. So I'm guessing that's where the unit comes in. Okay, so the velocity at 1 second is equal to the first derivative at 1 second. So this is 6 times 1 minus 6. So there's no change at 1 second. So this is going to be 6 minus 6 is 0 meters per second. Alright, and the acceleration at 1 second is 6 meters per second squared. Okay, great. And then S of t at 1 second, where is it at 1 second, is going to be the original function, 3 times 1, not t, but 1. Okay, 3 times 1 minus 1 squared minus 6 times 1 plus 1. So this is 3 minus 6 plus 1, which is negative 6, negative 4 meters. Interesting. Very interesting. Okay. Okay, so it's asking for dy dx, first derivative. It didn't solve the problem. So the derivative of sine is cosine. So this is cosine 6x times the derivative of what's inside the parentheses, which is 6. Okay. The second derivative equals the derivative of the derivative. The derivative of cosine is negative sine. So this is negative 6 sine 6x times, again, the derivative of what's inside. So this ends up being negative 36 sine 6x. Okay, so that's that. That's my final answer right here. Alrighty. Okay, so for this question, let's go ahead and just say, let's find the derivative with respect to x, the derivative with respect to y, and the total derivative. Okay, so partial derivative with respect to x would be, you are finding the derivative of x and making every other variable a constant. So this first one would be 3 plus the second one would be 2, since y is a constant, so it's just going to be tagging along 2y squared. And since y is a constant, that one you don't need to find the derivative of this because it doesn't have an x. Okay, the derivative with respect to y would be, this is a constant, so 0. The derivative of a constant is 0. 2xy squared, so that's 2y times 2x times the constant minus 8y 8y cubed. Simplify. So this is 4xy and 8y cubed. So that is the derivative with respect to y. So the total derivative is just putting them together and putting the derivative with respect to each variables together and just adding them together. So this is total derivative is 3 plus 2y squared dx. Okay, so show that that's derivative with respect to x, plus 4xy minus 8y cubed, and show that that's the derivative with respect to y. And so that represents the total derivative. So derivative with respect to x, derivative with respect to y, the total derivative. Okay. All right. Okay. Find where each is concave up, concave down. Find the intersection point. State whether it's a min or a max at each point. Okay, so pretty much answer everything you can. We are capable of that, so that's good. Good to be capable. Okay, so first things first. Find the critical points. Okay, so on the function, you want to find the critical point. Okay, so to find the critical point, find the first derivative. F prime of x which would be 12x squared. Okay, find the first derivative, equal it to 0, and solve for x. Well, x squared equals 0, so x, the critical point, is 0. Okay, so now find the second derivative and do the concavity test. Okay, second derivative test. Okay, so the second derivative, 24x. Okay, second derivative at the critical point is 0 because 24 times 0 is 0. So it looks like there is no, you can't really tell the second derivative fails, test fails. Okay, so this is just an inflection point at 0. Okay, so inflection point at x equals 0 and y equals negative 1. So if you were like, wow, that's different, and you wanted to graph that, you'll see is this cubic function that does not have a min or a max. Okay, so it's just an inflection point at 0, and it doesn't really have a definite min or a max. And cool, makes sense. Moving on. On the second one, similar questioning. All right, so same question here. First derivative is 3x squared minus 12x plus 9. Okay, so where is our first derivative? 0, because we need the critical points, and the critical points is wherever our first derivative is 0. So you take your first derivative, you equal it to 0, and you solve for your variable. So notice how all of these have 3 in common, so I can factor out a 3. 3 equals 0. And this is just x minus 3, x minus 1 equals 0. 3 equals 0, we can divide that out, so this we don't care about. Set everything else equal to 0. So x minus 3 equals 0, x minus 1 equals 0. Solve for x, so x equals 3, and we have another critical point here at positive 1. Okay, so the first derivative gives us the critical point because we just equal to 0, and we can find the critical point. Now we do the second derivative test to find the concavity. F double prime of x, the derivative of the derivative. So this would be 6x minus 12. Okay, so now we find it at the point, and what we care about is the sign of the second derivative at the point. So if we were to plug in 3 into the second derivative, you will have 6 times 3 minus 12. 6 times 3 is 18, minus 12 is a positive 6. Because this is a positive, this is concave up. Okay, so at 6, when x equals 3, you will have a concave up graph. Okay, the second derivative at 1 will be 6 times 1 minus 12, which will be negative 6 because it's a negative. This is a concave down at that point. Okay, so the actual point is when you plug in 3 to the function, to the original function. Okay, so when you plug it in, I'm going to use my calculator to make that really quick. So you have negative 3 cubed, minus 6 times 3 squared plus 9 times 3 plus 1. and that gives you negative 53. So this is the actual point on the graph. Okay, this point is concave up, and that means that this is a minimum point. Okay, if that confuses you, just remember concave up, draw it, and you see that concave up will give you a minimum point. Okay, um, at 1, at the point when x equals 1, you want to look at that, of course. So when x equals 1, y value, again, I'm using my calculator just to make it a little quicker. 1 cubed, 1, 1, 2, okay, let me spell that here. 5, 1, 5, great. 1, 5, that's my concave down, and a concave down will give you a maximum point on the graph. Okay, so this is a very loaded example because it's asking you for a lot of things. You can learn a lot from this one example. It's also asking you for an inflection point. Okay, inflection points are where the second derivative equals 0. Okay, so second derivative, so 6x minus 12 equals 0. Okay, add 12 to both sides. 6x equals positive 12, so x equals 2. Okay, so at x equals 2, y equals, so what y equals 2, 2, 2. X equals 2, y equals 3. That is the inflection point. That's when the graph decides to change direction. All right, all right. Okay, so 3 is on your own. If you understood how I did 2 and 1, you should be able to do 3. Thank you so much for this lovely, lovely time. Good luck.